To run a single application a few decades ago, companies had to purchase, store, and manage their own physical hardware. Owning the servers outright meant you absorbed entirely everything that came with them. If a hard drive failed, your team swapped it out. If the network went down, you rewired it. Your organization carried 100% of the maintenance burden and the security risk. Modern cloud computing removes that physical requirement. The National Institute of Standards and Technology defines the cloud as a model for enabling ubiquitous, on-demand network access to a shared pool of configurable computing resources. You can spin up servers, storage, and applications in seconds without ever touching a piece of metal. But renting shared resources located thousands of miles away introduces a specific tension. When a database crashes or a system is breached on an Amazon or Microsoft server, determining who is legally and functionally responsible can get blurry fast. Surviving in the cloud requires drawing a hard line between what you own and what you rent. This boundary dictates your legal liability, your daily task list, and how you design for a system failure. Before looking at the software abstractions that make cloud computing work, we have to define the physical geography of where the servers actually sit. The public cloud consists of shared global infrastructure. Cloud providers maintain networks of highly available, interconnected data centers across the world, which AWS refers to as availability zones. Anyone with an internet connection and a credit card can rent space here. The private cloud is the exact opposite. This is dedicated infrastructure isolated entirely for a single organization's use, completely walled off from the general public. The architectural bridge between these two environments is the hybrid cloud. A hybrid approach allows a company to keep highly sensitive data, like medical records or financial histories, locked down on private on-premise servers, while pushing heavy, resource-intensive computing tasks out to the public cloud. Choosing between these deployment models is an organizational calculation. You have to balance your requirement to scale quickly against your tolerance for privacy and risk. This diagram illustrates the shared responsibility stack. As you move vertically up the layers of cloud services, the provider handles more of the back-end maintenance, but you lose granular control over the environment. The foundational layer is infrastructure as a service, or IaaS. You are renting the digital equivalent of a bare metal server. The cloud provider secures the physical data center and supplies the power, but you are responsible for configuring the operating system, the networking, and the storage. Above that is platform as a service, or PaaS, which provides a complete, ready-to-use development environment. The provider now manages the operating system and the middleware. You just bring your application code and deploy it. The top tier is software as a service, or SaaS. These are fully baked, user-ready products like a web-based email client or a messaging app. The provider manages the entire stack, requiring zero infrastructure maintenance on your end. Understanding this vertical stack dictates your daily workload. The higher you build in the stack, the less infrastructure you manage, but the more you must rely on the provider's internal security protocols. Looking at this stack shows us exactly where the professional cloud engineer operates. They live entirely in the bottom two layers. Cloud engineers do not typically write the application code or build the SaaS interfaces that end users click on every day. Their core function is configuring the complex IaaS networks and PaaS environments that create a secure, highly available foundation for those software applications to run. To deploy this infrastructure safely, they build continuous integration and continuous deployment pipelines. CI/CD automates testing and deployment, replacing manual, error-prone terminal commands with controlled, repeatable processes. Operating in this gray area of shared responsibility means the engineer's ultimate role is implementing secure architecture by design across the boundary of what the provider handles and what the company controls. Mastering the shared responsibilities of the IaaS and PaaS layers allows you to build systems that are redundant, automated, and secure by design. It is the specific technical expertise required to move infrastructure out of the data center and into the code itself.